Surya Siddhanta is quite possibly humanity's oldest surviving textbook of astronomy. It's India's Ganika Jyotisha, which means it's the mathematical foundation upon which astrology is built. This is episode 2 in a series exploring the contents of Surya Siddhanta. To review, what we learned in the previous episode was Surya Siddhanta's definition of universal units of time. Because time defines space, because space is an evolved thing, and evolution requires time. So Surya Siddhanta gave us these basic units: breaths, semi-beats, and beats, days, months, and years, and cosmic days, cosmic months, and cosmic years. Then after defining these units, he jumped up to these very large cosmic durations of time by multiplying the cosmic year by 12,000 to get something called a yuga, or an age. And then again multiplying that age by 1,000 to get something called an eon, or a kalpa. And he gave ways to subdivide these huge units of times into smaller, more manageable units. So he gave 4 types of yugas within the yuga: the Krita, Treta, Dwarpa, and Kali. And he gave 14 Manu periods within the eon. Now when I say he, I'm referring to the author of Surya Siddhanta, Mayasura. So the Mayasura then finishes up the units of time by saying 2 of these eons is equivalent to 1 day for Brahma, and then Brahma has his own days, months, and years. That's the review. Now let's begin our new material with text 21, 22, and 23. This is going to explain to us approximately where we are right now in all of these cosmic time spans. Like, how long has it been since the universe started? So he says, Brahma lives for 100 of his years, and we are in the first eon of the second half of his life. So we're in the first day of the 51st year of his 100-year lifespan, which spans the whole 311 trillion years of the universe. Then he says, in that eon, 6 manus and transitions have passed. So an eon is 14. So again, we're about halfway through that first eon at the beginning of the second half of Brahma's life. Within the 7th Manu that we are in, which is called Vaivashvata, 27 ages have passed. Within one Manu, there'll be 71 ages, so kind of close to half of the ages within Manu have passed. So now we're in the 28th age, and within that 28th age, Krita has passed. Soon, in this very video, we will calculate the durations of all these things. The last statement that he makes right here is that time passed since Krita Yuga ends can be calculated. How can it be calculated? That's what he's going to explain, and that's what involves astronomy and astrology. Now I'll explain the basic idea of how you can calculate the time elapsed since Krita Yuga ended. The basic idea is exactly the same as if you say there's a bus at a station, it leaves the station, it drives 60 miles an hour in one direction, and right now it's 120 miles from the station. You could figure out how long ago it left the station. All you would have to do is divide 120 miles by 60 miles per hour, and you would know that the bus left 2 hours ago. That very simple kind of mechanic is exactly what the Surya Siddhanta is using to tell us how much time has elapsed since the end of Krita Yuga. Instead of the bus leaving a station, we're going to have planets leaving a certain point at a certain date. And instead of saying the bus drives at 60 miles an hour, he's going to say that the planets have these certain speeds with which they move. And instead of saying it's 120 miles from the station, you just look up in the sky and you see where they are currently. Then you can use those A, B, and C, just like you could figure out how long ago the bus left the station, you could figure out how long ago Krita Yuga ended. So there's 3 questions that we have to ask. There's 3 questions that Surya Siddhanta is going to explain. First of all, where do the planets start? Then how do we measure the distance that they travel? And how do we measure their speed, or what is their speed? So the first topic, where do the planets start? He addresses this in texts 25 through 27. He says the planets move westward, but slower than the stars, so they move eastward in comparison. So this is another simple principle of relative motion. You can get a sense for this if you just stop at a stoplight when you're driving, and if there's a car next to you in the other lane. Then when the light turns green, that guy goes forward a little slow and you go forward a little bit more quickly. Then what does that guy next to you look like? It looks like his car is moving backwards. Even though you're both moving forwards, he's moving forwards more slowly. So from your point of view, he's moving backwards. That's what he's saying here about planets and stars. Planets and stars are both moving west, but planets are not moving west as fast as the stars. So relative to the stars, the planets are moving east. So we're going to use the position of the stars relative to planets to measure where they are and where they start. The stars all move together, and because they all move together, it doesn't really make too much of a difference which star you pick to measure the planetary movement against. But we should probably pick one that's just convenient. In other words, convenient means the planets would be close to it. It would be close to the ecliptic. And maybe there's something special about one of the stars. We'll see. We'll see what Surya Siddhanta says. The stars move together. The planets, however, move at their own individual speeds because they have differently sized orbits. Faster planets have smaller orbits. Slower planets have larger orbits. This is very interesting. Here again, the Surya Siddhanta is quite sophisticated, and its concept is exactly the same as the modern astrophysics concept. Slower planets like Saturn are slower because they have to travel more distance because they have a bigger orbit. Now, the interesting thing about them all traveling at different speeds is that this is what allows us to measure very long units of time using the planets. If they all traveled at the same speed, then we can only measure up to that speed, right? Like Saturn, for example, travels at about one orbit per 27 years. So then how could you measure anything longer than 27 years using Saturn? But because they all have different speeds, we can measure the yugas, or the conjunctions of the planets, which will happen much more rarely, like Saturn's conjunction with Jupiter would happen every 48 years. And the conjunction of Saturn and Jupiter at a particular star would be even more of a long-term thing. Finally, he says, remember, smrta, remember, they all meet at Paushna at the end of yugas. Paushnante pagana smrta. So now he's answering the question of which star should we use. He wants us to use this particular star, Paushna, which is Zeta Piscium. And why? Because they all the planets meet at this star. And it also has a nice feature that it's right on the ecliptic. It's easy to see. So now we have an answer to our question of where do the planets start. The bus starts at the station. Where do the planets start? Well, they start at Paushna at certain fixed times, at the end of Krita, for example. Our next question is, how are we going to measure how far the planets have moved from Paushna or any other star? And he answers this in the 28th text. He says, their orbit divided into 12 arcs, and divide each one to 30 degrees, and divide each one into 60 minutes, and divide each one into 60 seconds. So now he's answered our second question. How do we measure distance? 60 seconds in a minute, 60 minutes in a degree, 30 degrees in an arc, 12 arcs in an orbit. Now we have our third question, which is how do we measure speed? And the answer to this is pretty much like miles per hour, except instead of miles, we're going to use orbits, and instead of hours, we're going to use ages. So we're going to measure the speed of planets by how many orbits they complete in an age. And the Surya Siddhanta gives us the miraculous definition of how many orbits each planet completes over the span of 4,320,000 years in an age. It does so in text 29 through 33. So it talks first about the orbits, which is called bhagana. The sun naturally does 4,320,000 because it orbits once per year. Every other planet is something close to a multiple of that. The moon is about 57 million per age, because that's about 12 times as fast as the sun. Mercury and Venus, they orbit with the sun, so it's the same amount as the sun, 4,320,000. Mars is half as fast, basically, as the sun, so it's about half as many orbits, 2 million something. Jupiter is about a 12th as fast as the sun, so it's about a 12th as many orbits, 364,000 orbits per age. Saturn is only 24th, close to about a 24th of the sun's speed, so it's 146 some odd thousand. And remember, this is traveling at a theoretical average speed. It's not actual exact speed or location, it's theoretical average speed. In addition to the orbit, he talks about something called Shigra. Shigra is what we would probably call in English parallax, which means the variation on the speed of something that you're looking at because of the fact that you're also moving. So he says that Mars, Jupiter, and Saturn, they have one Shigra rotation per year. This is because the change in the speed to the outer planets is because of the Earth's actual rotation around the sun. But Mercury and Venus, they have more than one per year. It's because their parallax is due to their motion around the sun. This line here is the line that describes the planet's revolution around the Earth. And this smaller line here, the smaller orbit here, is the Shigra, or the orbit of the Shigra, the parallax orbit. So in the case of the inner planets, what this Shigra orbit actually is the planet's true actual heliocentric orbit. And it's when you combine the actual heliocentric orbit of a planet called Shigra with the Bhagana, with the revolution of the planet around the Earth, apparently, the combination of these two things gives you this exact model of the planet's true movement. So Surya Siddhanta, the oldest astronomy text surviving in human history, has a merger of heliocentric and geocentric math to accurately describe the true motions of the planets. So we've answered a lot of questions. We've answered all of our questions, actually. We know where the bus starts, we know how to measure its distance, and we know how fast it's going. Now we can answer the question, how long ago was it that the bus left the station? How long ago was the end of Krita? Because at the end of Krita, we know where the planets all were. What you would do is you just take the number of revolutions described for each planet per age and try dividing it by numbers. If you divide it by 2, you get all these nice whole numbers. And what that means is the conjunction will occur. A whole number means the orbit will be perfectly completed. So the conjunction of all the planets will occur every 2,160,000 years, which is the same as saying every 6,000 celestial years. If you try to divide it by 3, the conjunctions don't occur on that tempo. If you try to divide it by 4, however, they do, with the exception of the lunar node. So you will get another conjunction of all planets at Pusha every 3,000 celestial years, or every 1,080,000 solar years, except for the node. The node will be halfway through its orbit instead of completed it. Then if you try to divide by 5, 6, 7, you don't get any luck. You don't find the conjunction on those divisors. But if you divide by 8, you get twice as many as dividing by 4, right? But you also get twice as many problems. You get Jupiter is also going to be out of sync. Now, if you think about the durations of the sub-ages, Krita, Treta, Dwarpa, and Kali, they're multiples of 12. But here, multiples of 12 celestial years. And here we're finding that this conjunction happens on multiples of 30 or 3 or something, right? 3,000. So we don't care about any conjunction that's not also a multiple of 12, because we can't use that conjunction to know when an age began or ended. So no matter how you divide it up by 2, 4, or 8, the only important conjunctions are the ones that happen at 6,000 and 12,000 celestial years. So every 2,160,000 solar years, we have a perfect conjunction. And that conjunction will define the end of Krita. And exactly 6,000 celestial years from the end of Krita is the end of Dwarpa. So this perfect conjunction at Pausha happens at the end of Krita and also at the end of Dwarpa. It happens twice per age. So another way to say it is the beginning of Treta and the beginning of Kali Yuga. There is a way, by the way, to know the difference between the two. The one that's at the end of Krita will have the lunar apsis at a certain point, and the one that's at the end of Dwarpa will have the lunar apsis at a different point. Now, astronomers and mathematicians like Aryabhatta and many, many others at all different centuries have used the current observed positions with this information in Surya Siddhanta to arrive at the actual date of the end of Dwarpa Yuga, or in other words, the actual beginning of Kali Yuga, and that is universally accepted as February 18th, 3102 BC on our calendar that we're familiar with. Now, one thing I want to say about this date, if you plug it into your software or something, you won't see all the planets aligning at Paushna, because he's not talking about actual motion of planets yet. He's going to start talking of actual motion in chapter 2. Now he's talking about the mean average motion. Now, before wrapping up this discussion on part 2 of chapter 1 of Surya Siddhanta, I promised that we would calculate basically where we are in the universal lifespan. And so here it is. You will get more information about this, more detail in part 3, and also there's more detail about the time units in part 1. So for example, the biggest time unit that we have is Brahma's life having been halfway past. To understand why it's that value, you need to watch part 1. Then we also heard that we're in the first eon. That eon has a sandhi, or a transition into it, which lasts 4,800 celestial years, so we need to include that. Then we were also informed that there's a creation period where nothing actually happens except Brahma creating stuff. Planets, stars, beings haven't been done yet. They haven't been released yet. They're still in beta. And that is 47,400 celestial years, so we need to add that in. That happens at the beginning of every eon, every Brahma's day. On top of that, we heard that 6 manus had passed, so that's 6 times 856,800 celestial years. And then on top of that, we heard that 27 yugas passed, so that's 27 times 12,000 celestial years. And we heard that Krita Yuga also passed, so that's another 4,800 celestial years. So we can sum all of that up and realize that this universe has been around for 432,5,427,000 celestial years. In solar years, that's 155,521,593,720,000 years. If we subtract the half of Brahma's life from that, then we realize how long ago the current aeon began. And that's significant because the current aeon is a complete destruction and then rebuilding. So we can understand that it is 1,953,720,000 years since the previous complete cosmic destruction. Or not absolutely complete, but very major cosmic destruction. Then if we calculate back to the beginning of the previous Manu, then we can know how long it's been since the previous lesser destruction or local cosmic destruction. And that would be 116,640,000 years. And finally, if we just consider Krita Yuga, then we can understand how long it's been since the last kind of earthly major change, which would be 1,728,000 years. But remember, this is as if we were currently at the end of Krita Yuga. So let's take a moment to address whether or not what we just heard supports a sidereal zodiac conception. Obviously, in all these calculations that we just learned, Paushna is very important. So people will want to know why. Why is Paushna important? And some people will say, well, it's important because Paushna, or Zeta Pisceum, is 0 degrees Aries. And that's the beginning of the zodiac. So let's ask the question, is Paushna the beginning of the zodiac according to Surya Siddhanta? Surya Siddhanta itself says no. Because in the 14th chapter, 7th text, it explicitly says the zodiac is based on something else. The start of the zodiac is directly tied to the position of the equinoxes and solstices, according to this text in Surya Siddhanta. Although Surya Siddhanta says, no, this is not the beginning of the zodiac, other people say, yes, it is. And they would do so for various reasons. Maybe some of them just want a reason to start the zodiac here and make the zodiac sidereal. Others, like Ebenezer Burgess, they are British Orientalists. So really, the Surya Siddhanta was first introduced to the English-speaking world through the British Orientalists, especially the translation and commentary of Ebenezer Burgess. And the amount of cultural racism in that translation and commentary is terrifying. Although the scientific part, mathematical part of his calculation is quite good. But his whole purpose in translating it is to show how India is naturally inferior to Britain. So they love the idea, people like Burgess, they love the idea that Paushna is the beginning of Aries. Because it means the Surya Siddhanta calculations are based on an author living at 500 AD. And if the Surya Siddhanta's author is at 500 AD, that means they got all this information from the Greeks. Which means British culture based on Greek and Rome is superior to Indian culture based on whatever kind of weird stuff it is based on. So, is this the beginning of the zodiac? No, it's not the beginning of the zodiac. Surya Siddhanta says the zodiac begins somewhere else, but other people want to say yes for whatever various reasons. So then, why is Paushna important? Is it the beginning of the nakshatras, maybe? No, also, it's not the beginning of the nakshatras. The nakshatras start from Kritika. Krita means start. The starting yuga is Krita Yuga. The Devata of Kritika is Agni. Agni means starter. Kritika is all about starting. And it's the start of the nakshatras. That's clear in all the Vedic lists. So then what is it about Paushna that makes it important? It's not the beginning of the zodiac. It's not the beginning of nakshatras. Why is it so crucial for these calculations? Again, really, it's just very, very simple why. The text itself says why. It's because all the planets align here. That's unique. Now, someone might say, but the next text after that, 128, says you got 12 arcs of 30 degrees of 60 minutes of 60 seconds. That's the zodiac, isn't it? So again, no, that's not the zodiac. What is it? It's what it says it is. What does it say it is? It says it's a way to measure an orbit. Any orbit. The zodiac is an orbit. And so since we use 12 arcs, 30 degrees, 60 minutes, 60 seconds to measure orbits, then naturally we use it to measure the zodiac. Guess what? We use this system to measure any circle, any orbital shape. Even if you're building the roof on a house, you measure it as 45 degrees. In fact, if you were in old India, you wouldn't even say 45 degrees, you would say 15 Taurus. Even though you're not talking about the zodiac at all, you're just talking about measurements of a circle. So what is this system of 12 arcs, 30 degrees, 60 minutes, 60 seconds? It's the natural way that we divide circles or orbits. And why? Why is it the natural way? These are natural or universal units of space because they're the natural universal units of time. So remember at the beginning of the chapter and what we reviewed at the beginning of this video, there's a year, and there's 12 months in the year, and there's 30 days in each month, and there's 60 beats in each day, and there's 60 semi-beats in each beat. That's why we divide circular things into 12 arcs, 30 degrees, 60 minutes, and 60 seconds. So that is the end of part 2 of chapter 1 of Surya Siddhanta. Here's the coming attractions for what we're going to look at in part 3. In part 3, Surya Siddhanta is going to tell us how to calculate the days passed since the last conjunction. And then how to divide that number in different ways to find out these very interesting things. The Lord of the day, month, and year. So like today is a Friday. Why? Why is it today's Venus's day? Besides that, it will show us the year within Jupiter's cycle. Jupiter has a cycle of 60 years, and you can figure out which of those years you are currently in by using this sum of days since the last conjunction. And finally, and probably the most universally important, is the position of any planet at any time. So stay tuned for part 3.